Here it says, two vertical poles of length 7 feet and 9 feet, so we see them in the picture here, so 7 feet here, 9 feet here, they're vertical, stand 10 feet apart. Okay, so this whole distance from here to here is 10, okay, and I'll talk about this labeling on the bottom in a second. A cable reaches from the top of one pole to some point on the ground, right, between the poles, and then to the top of the other pole. Where should this point be located to use 19 feet of cable? So the way that this is labeled here, okay, it's asking where it should be located. What it's doing is it's basically setting up an x-axis so that this distance right here, they're calling it x, okay? And then whatever that x is, let's say this x is 3 feet, right? If this is 3 feet, then we're basically saying it, right, this is how many feet from the smaller pole. So it's the number here, that's kind of the distance from right here, that's our x. So then what's this other distance right here? This distance right here is 10 minus x. So why is that? Because the whole distance is 10. So let's say this is 3, then the other 7 are here. If this is 4, the other 6 are here, right? So this plus this has to equal 10. So if we're calling this x, this here is 10 minus x. Okay, so the other thing that we need to know is we have a total of 19 feet of cable. So that means that this, right, this blue plus this red, right, those two have to equal 19. So what I'm going to do is I'm going to try to write this all in terms of x, okay? I'm going to start with this triangle, okay? And we're going to figure out what that blue hypotenuse is in terms of x. Okay, so I'm going to use the Pythagorean theorem. Okay, so maybe for right now, I'll just call this like h1 for hypotenuse 1. Okay, so what do I get? I get x squared plus 7 squared equals h1 squared. Okay, we'll call it something else in a minute, but we'll leave it for that. We'll give it a name in terms of x. So this is going to be x squared plus 49 equals hypotenuse 1 squared. So our hypotenuse 1 is, we can take the square root of both sides, the square root of x squared plus 49. Okay, so what I'm going to do now is I'm just going to pretend I never called it h1, and I'm just going to now label this side of the equation x squared plus 49, square root of x squared plus 49, right? So that's what this blue distance is. Okay, let's do the same thing for the red distance, okay? For now, I can call it h2 for hypotenuse number 2, but we're going to get rid of that in a few minutes. Okay, so Pythagorean theorem says 10 minus x squared plus 9 squared equals h2 squared. Okay, so now to simplify this, you could use a formula for squaring a binomial, but I'm just going to actually just write it out twice so that we can see what we're doing. Okay, so using kind of a FOIL process, right, 10 times 10 is 100, minus 10x, I'll write it out. So I get minus 10x, and then another minus 10x, and then plus x squared, and then 9 squared is 81, equals h2 squared. So let's combine like terms. So I have 100 plus 81, so 181, minus 20x, plus x squared, equals h2 squared. So now I can take the square root of both sides. So the square root of 181 minus 20x plus x squared equals h2. So I don't have to call it h2 anymore. Let's erase that. I can write it all in terms of x. So this red is now the square root of 181 minus 20x plus x squared. Okay, so now we're going to use the fact that there's a total of 19 feet of cable, meaning the blue distance plus the red distance has to equal 19. So let's write this all out, and I'll keep the color coding just for another line. So the length of the blue cable, which is the square root of x squared plus 49, plus the red cable, the red thing, okay, is 181 minus 20x plus x squared, the square root of that, and those two things have to add up to be 19. Okay, so how do we solve this equation? Basically, the way that we need to undo square roots is by squaring them, okay? If I want to, I can square both sides of the equation here. Remember, I would have to FOIL this out. It's usually a little bit easier if I only have one square root on each side, even though if I subtract something, I'm still going to have to use FOIL, like over on this side, but you can absolutely, if you wanted to, just square both sides from here. I'm not going to do that. I think it's a little bit easier to, I'm going to subtract this blue one from both sides. You can also subtract the red one from both sides. It's just going to work out a little bit easier, I think, if we do this. So we're going to subtract this from both sides. These are going to cancel. So we're going to be left with, I'll keep the red for just one, 181 minus 20x plus x squared, that's all inside a square root, equals 19 minus the square root of x squared plus 49. Okay, so now I'm going to square both sides. Okay, and you can see it just made my life a little bit easier because this side, the squares are going to kind of cancel each other out. The square root will cancel with that square. And then on the other side, we do have a little bit more work to do, but let's at least do this. So we have 181 minus 20x plus x squared. That's no longer inside the square root because you square root and then you square it. Okay. Over here on this side, okay, let's write this. Let's remind ourselves that this is 19 minus the square root of x squared plus 49 times another 19 minus the square root of x squared plus 49. Okay. So let's keep multiplying. Oop. Okay, and we still have this on the same side, 181 minus 20x plus x squared equals, okay, so 19 times 19, okay, I just put that into my calculator, it is 361. Okay, here I have 19 times the square root of x squared plus 49. Here I'm going to have another, sorry, this is going to end up being negative. Those are not going to cancel out. Let's erase that. It's not erasing for me. There we go. So sorry, this one is negative because it multiplied by that negative. This one's also going to be negative, minus 19 root x squared plus 49. And then when I multiply these two together, negative times negative is positive. And then square root of x squared plus 49 times another square root of x squared plus 49. Well, what we get back is just the original x squared plus 49. Okay, so now let's just simplify. 181 minus 20x plus x squared equals 361. So I have 19 of these square roots. Actually, let's get rid of that 361 because I can simplify that by adding to the 49. So 361 plus 49 is 410. Okay, and then here I'm going to just add that x squared in here, plus x squared. And then here, I have negative 19 of these square roots, and I have another negative 19 of these square roots. So I'm going to have negative 38 square roots of x squared plus 49. Okay, I'm making some progress. I still have a square root here. So I'm still going to have to go through a step where I have to square both sides to get rid of that square root. Okay, so we've made progress, right? We used to have 2 square roots. I squared both sides. I have 1 square root, okay? And just like before, if I wanted to, I could square both sides here, but it's not a good idea, right? I really would like to have just a single square root on this side of the equation before I start squaring both sides. So let's start moving stuff over. So let's subtract 410 from both sides. Let's subtract x squared from both sides, okay? So these are going to cancel, okay? And then I just need to do 181 minus 410. Okay, so over here, I have negative 229 minus 20x equals negative 38 times the square root of x squared plus 49. Okay, so if I wanted to, I could divide both sides by 38 at this point, negative 38 at this point. I'm not going to. I'll just square both sides with that in it. It won't make me have to start foiling out, so I'm okay with that. On this side I have to, but I'm not going to have to on this side because it's not being added, it's just being multiplied. Okay, so here I'm going to take a little shortcut, right? You could multiply this twice, right? Write it out twice, FOIL it out. I am going to use a little shortcut that just says, as a reminder, if you have like a plus b squared, it's a squared plus 2ab plus b squared, okay? Okay, so over here, 229 squared, I use my calculator, it is 52,441. So, and then we're going to have this 2ab because basically the 229 will multiply by the 20x kind of twice. Kind of like here, we had this times this and this times this, and because it was squared, it was the same thing. So I need to do 229, negative 229 times negative 20 times 2. So that's going to come out to be, plus 9160x. And now I'm squaring this, so it's negative 20 squared, so positive 400, and then the x squared, so plus 400 x squared. Okay, now on this side of the equation, right, notice these aren't being added or subtracted. These are just being multiplied, right? So when I'm squaring this, I'm just squaring the negative 38, which is going to be 1,444, and then I'm squaring the radical, which is x squared plus 49, no square root. So now I'm in a great spot because I no longer have any radicals. I just have a quadratic equation, and I can simplify from here. So let's distribute this. So I get 52,441 plus 9160x plus 400x squared. So I have 1444x squared, and then plus, I have to multiply 1444 by 49. And that is going to give me 70,756. Okay, and now I want to, if I'm going to put this into the quadratic formula, I want everything on one side of the equation. I'm going to put it on this side, even though I've got 3 terms here, because I like having a positive coefficient on my x squared. Actually, no, let's just do it. Let's leave it on this side. No, all right, we're going to do it on this side. And actually, here, let's try to make it like I'm going to leave some space here. So what was that? That was 70,756, just so that we can kind of put our x squared term, then our x term, then our constant term. So it's kind of lined up the way that we expect it to be lined up for that quadratic formula. So minus 400x squared, minus 400x squared. I'll do it in a minute. Minus 9160x. I'm going to put this in that blank space. 9160x. Those will cancel. And then minus 52,441. Minus 52,441. Okay, so what do I have now? 1444 minus 400 is 1,044x squared. I have 0 over here. Minus 9160x. And then I put this into my calculator. This was 18,315. Okay, so this is now all ready to go into the quadratic formula. So what do I get? For my quadratic formula, x equals, so negative b, so positive 9160, plus or minus the square root of b squared, 9160 squared, minus 4 times a, which is 1044, times c, which is 18,315, all over 2a, which is 2 times 1044. And I think it wanted us to round, what's going on? It wanted, oh, there we go. It wanted us to round to 3 decimal places, I think. I'm getting 5.69, and then I'm going to round up to 2, and 3.082. And actually notice that both of these answers are between 0 and 10, okay? It's possible to have gotten an answer that wasn't between 0 and 10, right? But remember that there's 10, right? If we remember, like we had these poles, right? There's 10 feet right here, okay? And x was labeling kind of the distance, this distance right here, right? So if I'd gotten something that was like negative or something that was more than 10, that wouldn't actually be realistic to this situation. It would be an extraneous solution. But actually, right, we actually have 2 different solutions that are between 0 and 10, which means that either of these work. You could have this set up so that the x is 3.082, right? Or you actually could have it set up so the x is a little bit farther over, right, at 5.692. And actually, both of them would lead to using 19 19 feet, I think it was meters of wire. Okay, so we actually have two different solutions. So we can enter both of these in as solutions.